Hmm. Hi, hey guys, welcome back to my channel. Today I'm gonna talk about the sliding window. Basically, let me just tell what I'm gonna do. Like I'm gonna create a playlist which list all the important problems which will be required to which you can solve to get into a decent product-based company. So I will be covering a list of topics like sliding window, heap, binary search stack, and recursion DP, trees graph, and then remaining topics like backtracking, greedy, try, and victories. So these are the topics I'm going to cover. And first, I'm going to start with the sliding window. So, like before starting any topic, I'll teach you the theory, like the just basic of the theory, and I won't be covering much detail. So if you aren't able to understand from my video, I'm sorry for that, and you can just watch any other video on YouTube like that. So I'm just gonna cover the basic theory of the sliding window, and then I'm gonna solve a few certain problems. And in this video, I'm just gonna solve the first one problem in the sliding window, that is touching the theory, and remaining problems will be solved in the subsequent videos. So and thank you for watching this video, and let's just get into it. So, sliding window, in if you gonna look at the problem of sliding window, in the given problem, they will have mentioned the three things. One, they would have given an array, and like mostly 90% of the sliding window problem will be given an array, or sometimes they would deal with the string as well. So, next part, they will give the size of the subarray, and this size of the subarray, which we directly call it as this thing, window length. That's what we call it as an like other name for the size of the subarray, as a window length. And third thing is that from the like these two things, they will be asking us to find something from the subarray, like find the maximum from the subarray, or find the minimum sum, like minimum sum subarray, or something like that. And this is how the sliding window will be like whenever you look at an given problem, if the array is given, and if the subarray size is given, then 90 to 95% it can be solved with the sliding window concept. So that's how we can identify whether a given problem is sliding window or not. So let's say if we talk about like this problem, find the maximum number from a subarray. Let's say we have given an array like 253 2971, and the size of the subarray is 3. And say, you know that what is a subarray, right? If anyone doesn't know, I'll just say the size subarray is any continuous part of an array. So size of the subarray is 3. Now, one possibility is that it can be 253. Next possibility is that it will be 532, and next possibility is that it will be 2329, and next one is 297, and another one is 9, 7, and 1. So we need to get the maximum from the subarray, and the maximum from this first subarray is 5, and then maximum from next subarray is also 5, and next subarray is 9, next one is 7, and final one is, sorry, next one is also 9, and final one is also 9. So we need to get the maximum of all the maximum from the subarray, which is the 9. In brute force way, how will you solve this problem? Let's say, and you will have an one for loop, and which will be traversing from the beginning to the end, and next for loop will be traversing from the, let's say this one, outer for loop deals with the I beginning from the end, and inner for loop will be dealing with that ith point, and then till I plus size of the subarray. Yeah, I'm doing not in the size of the subarray as hash. I'm so lazy, sorry for that. And till then, and then you will get the, what will you do? You will get the maximum from that max this thing, from that inner array, which is that this thing from subarray, and from out, once you get outside, you will have an global max, and then and we will compare it to the local max, and then global max while updating the global max. That's how you will do the brute force. Brute force looks like an n, and then this one is size of the subarray is k, like it will be an o of n k. And it will be a problem if k is large, right? Yeah. So yeah, that's how it goes. And like we can see it is around low of n square as well. Like now we need to improvise the we just remove the repetitive work. And you can anyone who weren't able to identify what's the repetitive work is, I have added the two hint here. And first hint is just remove the first element from the window and add the last element from the window. Once you move on to the next window, first window is 0, 1 and 2, and next window will be 1, 2 and 3. And so which one is added with the C before that, just see which is the new element coming to the group, which is the element which is leaving the group. See, in the second window, 0 is the one leaving the group and 3 is the one which is coming to the group. So just remove the first element of the window. First element of the window is 0 here, and add the last element of the window, which is 3 here. So that's how the one way we can improve the repetitive, we can just remove the repetitive work. And see, and I have written this thing, so window size remains the same. And just by doing that, just removing the first element of the window and adding the last element of the window size is still maintained. Like initial window size is 3 and now it's also 3. If you move on to the next thing, next let's say this is the new window and we will be removing, I'm sorry. We will be removing the one and we will be adding the fourth part. Still, the window size is 3. So, window size still remains the same. And you will appreciate this work just by like what work, like removing the first element and adding the last element. That work you will make, it will make sense when the window size is huge. When here the window size is 3, that's why it doesn't make much sense. If the window size is much larger, like 12, 13 and 14 or 15, then that time you will appreciate, like we can just avoid this part rather than again and again going from I to I plus hash thing, I plus 12 again and again. So that's what these two part are just added, which makes us the concept of the sliding window. So this is what I have explained here. Just remove the first element and add the last element to move to the window. Yeah. See. Like just by removing the first element and adding the new element, what are we doing? We are moving to the window. Like if, for example, if we have a two pointer like I and J pointing at that initial position. And pointing at the initial position, let's say j is increasing, and j is increasing, like j is becoming 1. Let's say this is 0 base indexing 0, 1 and 2, and j is increasing from 1 2, and let's say j has come to the 2 position, and window size is achieved, like in from I to j. And I to j it is achieved. Now we need to move the window. Once, like the only effort you need to make when till when the window size need to be achieved. Once the window size is achieved, you just need to maintain the window size. So once maintaining work is done, the problem is solved. So maintain the window size is like that's why I told, like remove the first element. How will you remove the first element? Just skip through this element, like I increase the I, yeah, I will become 1. And add the new element. How will you add the new element? Just move the j to the next pointer, and j will become 4. And still the window size is maintained. And just removing and adding, that makes the concept of moving through the window. We are indirectly moving through the window. Understood, right? And no need to explain much more than this. And yeah, next is the identification. Since initially itself I have already told you how to identify a problem, whether it is a sliding window or not. And for your information, I'll revise through it. And one more thing is that there are two types of sliding window. One is the fixed size sliding window, and another one is the variable size sliding window. And so in any sliding window problem, in any given problem, first see whether the given problem is an array or a string, and plus, and this is given. And one more thing you need to check whether it is given or not. The question should talk about subarray or substring. If these two are satisfied, and look for the third condition. These two are fixed. First condition and second condition are fixed. Third condition is the one which keeps changing. Third condition is that for a fixed size sliding window, window size will be given, and what will be asked is based on that window size. We need to find the largest, smallest, or maximum from that given window size. Just if you don't understand what's the window size is, just say that the other name for window size is the length of the subarray. So subarray is length of the subarray is given. We need to find based on that find the largest, maximum, or smallest value from the given k length of the subarray. That makes up the fixed size sliding window. For example, it will be question will be like find the maximum sum of subarray length 5. See, the question talks about the array or a string, and I mean the question is on the array or a string, and question talks about subarray and subarray. So second condition is satisfied, and for a fixed size sliding window, window size is given. See, and they won't spoon feed you like that. Directly give the window size. They will be directly indirectly giving the word, like the length. We just need to identify like the length is the window size. Subarray length is 5 means it is the window size, and they are asking the maximum sum. See, based on that window size, they are asking something that makes up the fixed size sliding window. It's kind of like tongue twister. Next comes the variable size sliding window. It's kind of a vice versa fixed size sliding window. They'll give the largest, smallest, and sorry. They'll give the quantity or a condition, and I mean this is what it is asked in the fixed size sliding window. The which will be given in the variable size sliding window. Quantity or condition will be given, and what will be asked is Oh, yeah. What will be asked is the largest, smallest, or the window size. The window size is basically asked, and the quantity or condition is given. Now, in the fixed size sliding window, the window size is given, and the quantity or condition is asked. I mean, the quantity is asked based on the condition. Here, the quantity or condition is given, and the window size is asked. For example, find the length of the largest subarray whose sum is 5. See, question is on array, and it talks about subarray, and what they have given sum is 5, not the length is 5. Sum is 5, which means the quantity or condition is given, and we need to find the uh, window size. We don't know what will be the window size, but we need to find the window size. That's what the problem is. Find the largest length, like largest window size or the smallest window size. That makes up the variable size sliding window. Note output array length. See, what do you say? Like, mm, yeah. See, like no. Next point is comes of the output array length. Output array length is let's say we have given an array, right? This array length is 1 2 3 4 5 and 6, and output array length is like how do I say, let's say you are getting the sum of, let's like it will make this point will make sense in the later part, and then I'll just tell you once the time comes. So now let us move on to the fixed size sliding window, the model code. Then how we can just substitute the part wherever it is needed, and remaining part will just remain the same. And see, now in this thing model code, I will have few what do I say, the pre definitions of some variables like that. So it will depend on person to person. In my point of view, I have kept like this. I've hashed the symbol. I have kept it for given window size, and there are two pointers which will define the custom current window size, my current window size, and hash is the like desired window size we need to achieve, and like two pointers I and j. And how will you find the current window size from I and j? And it will be j minus I plus 1. For example, if you have doubt, and just let's see, like, mm, this is 0, and this is 1, and this is 2. Let's say I is at 0, and j is at 2, and yeah, J is bad. And J is at 2. What is the window size? J minus I plus 1. 2 minus 0 plus 1. 1, 2, and 3. 3 is the window size, right? So its formula is correct. J minus I plus 1 makes up the window size, and hash is the desired window size we need to achieve. And what else is there? Where will I start? See, so I and j will initially will be at zero initial position. I equal to j equal to zero, and what we need to do is we need to increase our window size and till like till when the code will be running is like till the j the let's say the array size is something n or or the something like end and sorry end and till the j is less than end, until then the whole code will be running inside that. So if the j crosses the end, it will be of meaningless, right? It is of no use. So until the j is till before the end, will the code will be running and initialize I equal to j equal to 0 before this running the loop. And after that, and just increase our current window size. And if if it is less than the desired window size, what is our current window size? J minus I plus 1. If it is less than the desired window size, just increase the j. And once our window size is achieved, like j minus I plus 1 equal to k, then maintain that size. And what is the case, whether you are solving the problem or not solving the problem, just maintain the size, don't lose it. How will you maintain the size? Just increase the I and increase the j, like increase the I by 1 and increase the j by 1. That's all the basic code of this slide fixed size setting window. Let me further simple you down. Break you down further. Break it down how to write the code. Let's, as I said, why we'll be running the code till j is less than size, and then like just don't look at this part. I'll come at the later point. Do some like shit do some calculation part here. And if just measure that our current window size like j minus I plus 1 is less than the desired window size, so increase the j so that our window size will be increased. If it has been else if it has been achieved, then do something. I don't care what you do, just do something and maintain the window size. This is the main thing. Whether you are doing this or not, whether you are doing this or not, if the window size is less, increase the J. If the window size is achieved, just maintain it. That's all I care, and that's all that matters. Let's say I'm solving a problem like this is the same problem like maximum sum subarray of size k, and this is the this comes under fixed size setting window. How am I saying is it's see now you should tell me how it is a fixed size setting window. I have already explained a lot to you how it is fixed size setting window. As I said, what makes a fixed size setting window? First, check these two part. The two questions should talk about an array. Yeah, array is given, and question should be of array or string, and question should talk about subarray or substring. Yeah, question is talking about subarray or substring, and yeah, what else is there? And window size is window for a fixed size setting window. Window size should be given, and this should be asked. Largest, maximum, or smaller should be asked. Window size n and a number k, and return the maximum sum of subarray of size k. Yeah, window size is given, and we are asked maximum sum. Yeah, now not just the sum, it is the maximum sum. That's what matters. Yeah, maximum sum. So this comes under fixed size setting window, and we'll just follow the more code like base code which I have defined. So we will be running the this thing loop, like we'll be running the whole code till this one is achieved, like j is less than the size, and initialize I equal to j equal to 0 and sum is equal to 0, max global maximum I'm maintaining, initialize with the int like minimum part, and till the j is less than the end, and end is the n, right? So yeah, j is less than n, and do some calculation. Like what calculation I'm doing, I'm adding it to the sum variable, and I'm adding, that's the calculation I'm doing here. And if the our current window size is less than the desired window size, I'm increasing j. And else if this is achieved, and what I'm doing is, if this is achieved, the final calculation, the final calculation this talks about the final calculation. What is the final calculation is, I am like this thing, I'm updating the global maximum sum. Like if the previous maximum is smaller than the current sum, I mean the previous maximum is smaller than the current sum, then I will be updated to it. And now we need to maintain the window size. By maintaining the window sizes, I will be increasing the I and I will be increasing the j. And as I said before, where did I say here? For to maintain the window size, just by increasing the I and just by increasing the j, it doesn't solve by that. We need to remove the previous, like the first element. I mean, we need to remove the first element of the window. Like if we didn't remove the first element of the window, it will keep on tagging on with the next window. You will be maintaining the window size, but you won't be maintaining the sum of that window size. To also maintain the sum of the window size, you need to remove that first element of the sum, and no need to add the last element of the sum. It will be automatically added once it will be looped. So just return the max sum at the end. So I hope you would have understood this thing, fixed size sliding window, and I'll make the model code for the variable size sliding window once I'll solve the problem for a variable size sliding window. So yeah, then next few videos will be on the few uh, problems on fixed size sliding window, and afterwards I will start the variable size sliding window. That time I will give you the model code of the variable size sliding window. So thanks for watching with this video, and don't forget to like, subscribe, and share it with your friends. Bye.